What we are looking at today, we talked last time about how we can use row reduction to solve a system of equations, how we said we need to get into row echelon form, eventually into reduced row echelon form, and therefore be able to solve a system. Today we want to actually look at what steps we take to do so, to be able to solve these. These are the recommended steps that we are to take. We start by eliminating something in the bottom left corner, then everything else below the diagonal. Then that will create us a row echelon form matrix, or we also call this a triangular matrix, upper triangular to be exact. We then make the lowest pivot position equal to 1, and then eliminate everything above that pivot position, and then all other pivot positions after that. We do not touch the top row of the matrix until the very last minute. When we try to make these pivot positions equal to 1, we do it by dividing, and then in the very end we have something that will look like an identity matrix. So like if it was a 3 by 3, this is what your matrix would look like. It'd be like maybe 2, 3, negative 5. That means our answer would be x is 2, y is 3, and z is negative 5. That's our goal in the end. So the row operations we are allowed to use are just these three. The first one is to interchange any two rows, multiply all the elements of a row by the same number, and replacing a row by the sum of that row and a multiple of another. What we will normally do is, instead of saying a multiple of another, we just will add two rows together. So just so you can see, if this is our original matrix, I can swap any row for any reason. So in this case, I swapped row 2 and 3. For the second one here in purple, I multiplied the third row by 2. That way I could go and eliminate, if I wanted to, I could add row 1 and row 3 together. They're the exact same number now. And in this last one, replacing a row by the sum of it in another. So row 2 and row 3 and plugging it into row 3. So row 2 plus row 3 gives you 0. That's how I got 0 here. 0 and 3 gives you 3. 4 and negative 2 gives you 2. Those are your elementary row operations. And again, our goal in the end is to get it to look like this identity matrix. And here's the big idea. When you do this row reduction, no matter what matrix you start with, no matter what steps you take, because there are many different ways to do this, you should always get one exact equivalent matrix in row echelon form. So essentially, no matter what, you should get one guaranteed answer when it's in this reduced row echelon form. That's the beginning. If you will look at the next video, you'll see a brief example of, well, I shouldn't say brief, this is one of the more complicated ones, of a system of a 3 by 3. This is what it's to look like. Go ahead and check out the next video to see how you would solve these.